Coming to the design of one-way slab. Step number 1, determine the effective depth. Page number 37 of IS 456. There is a class. Page number 37 of IS 456. There is a class on effective depth. See, for cantilever, span to effective depth will be 7. For simply supported, span to effective depth is 20. For continuous, span to effective depth is 26. Generally, we will design this one-way slab as a simply supported. That's why span to effective depth ratio will be considered as 20 as per IS 456. That is step number 1. Step number 2, determine the loads. Step number 3, compute the design forces. That is maximum ultimate bending moment WL square by 8 and shear force WL by 2. Step number 4, compute minimum effective depth required to resist the moment of resistance. Earlier, here we have fixed some depth. We need to check whether the depth is sufficient or not to resist this moment. That's why here, based on the steel we use, we will take the ultimate moment of resistance 0.138 FCK BT square for Fe 415, 0.148 FCK BT square for 250 steel, 0.133 FCK BT square for Fe 500. Right? MU is from step 3. This MU value we need to take here. From here we need to determine the depth value. This depth value should be less than the depth provided in the step 1. Okay? Then no issue. If the depth is not sufficient, we need to move with this depth only. The depth what we get in this step, this depth need to be fixed. Right? Step number 5. Compute the area of steel. To compute the area, you can take the moment of resistance equation from page number 96 annex G. You can see this equation in this page. 0.87 FIAST multiplied by D into 1 minus FIAST by FCK into B times D. From here, you can determine the AST value. This AST value should be greater than 0.12% of B times D. This statement will be in the page of 48. I will show you that statement. Page number 48. See, minimum reinforcement. See here. For mild steel reinforcement in either direction in slabs shall not be less than 0.15% of total cross-sectional area. For mild steel, it is 0.15%. For other steels, it is 0.12%. For HYST, it is 0.12%. That's why the steel we provided should be greater than 0.12% of gross cross-sectional area, that is B times D. Next, step number 6, spacing. Already we know how to provide the spacing. Spacing is equal to the area of the steel we provided divided by this AST multiplied by 100. Multiplied by 1000. Right? This spacing should be less than 3 times of the diameter or 300 mm, whichever is less. This spacing should be less than 3D or 300 mm. This statement you can see in page number 46. Page number 46. Page number 46. See here. See here. The horizontal distance between parallel main reinforcement bars shall not be more than 3 times of effective depth, means 3D, or 300 mm, whichever is smaller. Right? That's why I have taken this statement. In the case, step number 7, we need to determine the distribution still. Simply, you can provide the distribution still with the amount of 0.12% of BD, and we can calculate the spacing as above. This spacing should not be should not be greater than 5 times of D or 450 mm, whichever is less. This statement is also available in page number 46. See here. The horizontal distance between parallel reinforcement bars provided against shrinkage and temperature shall not be more than 5 times of effective depth or 450 mm. 5 times of effective depth or 450 mm, whichever is less. Right? Like this, we need to design a one-way slab. Once we designed the reinforcement and dimensions of the beam, we need to check for shear and check for development length and check for deflection. Already we discussed about the check for shear and development length and deflection in earlier classes. Right? Coming to the detailing of a one-way slab, as I said, generally the one-way slab will bend in this direction. Suppose this will bend in this direction. That's why we need to provide the main reinforcement in this direction. This is the main reinforcement. See, you can see here. This is the main reinforcement. This is the main reinforcement. Right? The distribution still need to be provided like this. Right? This is the distribution still. This one. This is the distribution still. Right? The distance of this distance will be 0.1 L. Generally, we will take 0.1 L. Right? We need to bend at least 0.5% of area of the steel. That we will discuss in future. Right? This is about the detailing of one-way slab.